Researching Flat Earth, Part 2. I want to make a short presentation, talk about the Arctic midnight sun and Antarctic midnight sun. I've seen people from the Flat Earth community say there is no South Pole 24-hour sun. Well, yeah, I want to take a look at it a different way. I mean, unless you got 6 or 10 grand, you're probably not going to go to Antarctica to go see it. And I'm not sure I would spend that kind of money just to go see a bunch of ice and snow and maybe some penguins. I'm sure it's very beautiful. If I had a lot of excess cash, I might do that, but maybe not. Oh, by the way, the eclipse doesn't look like this picture. I was just horsing around with my some of my pictures that I took. So anyway, I was taking a look at Tierra del Fuego here on the southern tip of South America. It's pretty far south. I thought we should take a close look at the daylight hours there. I've heard that since there's no 24-hour sun, and if the sun's a spotlight beam, you know, one would expect that you wouldn't get a lot of daylight hours in Tierra del Fuego. But let's take a look at this using some data. Decided to use the flat Earth map. And taking a look at, I got Miami here at 10 hours and 31 minutes, and Ecuador at 12. Santiago at 14 hours and 22 minutes. This is all on the December solstice, where Tierra del Fuego has 17 hours of daylight. 17 hours. So, I mean, I took a number of places up and down the map here. I took them at different latitudes. So we know the latitudes. That's those circles, right? I took it to San Francisco. I took Nome, Alaska. I took a lot of these places and said, how many hours of daylight do they have at the December solstice? And I plotted them. And this is what the plot looks like. Now, I also plotted McMurdo Station on there, but they report 24 hours of daylight. Now, I put it as 0000. That's just the way the Google plotting thing worked. It should have said 24, but it's wrapped back around because it's a time. But you can see the latitude on the vertical axis there, and then the hours of daylight. And even if you take McMurdo Station off here, it's not too hard to figure out where that curve is going. I mean, it sure looks like the bottom part of that chart should look like the top part of that chart. And so this one's pretty easy. It's obvious there's a 24-hour sun at the South Pole from this chart. Now, what happens when you go to the June solstice? Now we have a 24-hour sun at the north, above 75 degrees latitude. And when I go down below 75 degrees latitude south, I've got 0 hours. And now this curve looks very similar to the other one. Back to back, it's fairly obvious. The symmetry there is very telling. So, make what you will of that, but that's data. And, I'd like someone from the Flat Earth community to please explain this. Even if I take McMurdo Station off, please explain this, or see if you can explain this with any of your models. Now, here's your model for a refresher. In June, you think it's a circular spotlight, which is kind of odd. During the, but I mean, at least possible in June. I look at the equinox in March and September. I get a D shape. And how in the world do you get a D-shaped light source? Now, I've seen people with some lenses and, trying to different angles on a circular magnifier and stuff, trying to duplicate the one on the right there in December, and halfway do it, but certainly with nothing that you could observe in the real world. So, I don't know, you tell me, how is that D-shaped light source pattern shaped? And then how does that hours of daylight all up and down the globe, all up and down the world, how is that even possible? I'd really like to hear an explanation. Anyway, thanks for watching, and best of luck to you.